there are places like Enceladus, the icy moon of Saturn, that we know has an abundance of liquid water and organic compounds. We have found organics on Mars, and there's certainly evidence for liquid water in its past. But in the present day, Enceladus has abundant organics and liquid water. So if you want to look for living microbes that are alive today, I would have thought going and collecting a sample from Enceladus, from the plumes of Enceladus, would be an obvious thing to do.
Hello from the children of planet Earth.
Super. Charles, thank you very, very much. We appreciate you coming onto the channel.
Thanks a lot. Thanks for inviting me. It's good to be here.
Super. In a world of my understanding now of astrobiologists being in some ways the rock stars of scientists, you seem to be a rock star of astrobiologists in terms of the amount of work that you've done and contributions to the field.
That sort of horrifies me. I certainly don't try and be a rock star as a scientist. I think, it thrills me that the whole scientific area and questions about astrobiology, life on the Earth, history of life on Earth, possibility of life elsewhere. I also have to think it's exciting and important to explain these things to a wider audience. So I've certainly done some of that as well. But yeah, it's a field I'm particularly enthusiastic about.
The conversation around what are the boundaries of life, what are the boundaries of intelligent life, and how there's not necessarily disagreement, but there's, is a virus alive, or there isn't. I think it's a difficult question to a difficult subject to just go that this is what life is.
Yeah, we could get into a long discussion here, and it very quickly degenerates into personal views. I mean, my own view, it's not my particular original view, other people hold this as well, I think, is that life is just a definitional word that humans dreamt up, a hive-off part of organic chemistry that's interesting. There are these lumps of matter in the universe that reproduce and evolve, and we happen to be among them. And we get very interested in that. And it is interesting stuff, a lump of material that has a code in it that changes over generations and turns from microbes into kangaroos. This is an extraordinarily interesting phenomenon. So we want to draw a line between that and other material. So we come up with this word life. And of course, there are very strong religious and other proclivities and demands for doing that, to accept the fact that you're just a lump of replicating, evolving organic material is something a lot of people are not very comfortable with. So we like this word life, and we use that to hive off this part of the material universe. But I think that you bring up viruses, of course, that can replicate, but only inside a cell, and outside a cell they can't, and so therefore they're dead. But of course, as has been pointed out before, you could say the same thing of a rabbit. A rabbit cannot replicate unless it has another rabbit. So does that mean that a rabbit on its own is not alive, and it's only alive when it finds a mate? And I think most of us would think that a lone rabbit is alive. So it's not that different from a virus. But the point you get is that this definition, once you start to look around the edges, falls apart. You can always find these examples of things that don't really quite fit the definition. And that, to me, is an illustration of the fact the word life is just a definition, and it's not really anything that you can define in physical terms. Yeah.
So you talk about Mars. I mean, you've done quite a bit of work with a range of different organizations around Mars and exploration. Can you talk a bit about some of the projects that you've done?
Yeah, some of the projects we've done is looking at how microbes can survive in briny environments on Mars, trying to understand how brines influence the habitability of extraterrestrial environments, and what the limits are to life on Mars. We've also been interested in projects on the preservation of microorganisms on Mars in extreme environments, and trying to understand how we could use microbes on Mars to do useful things. It's not just about search for life. We've also done experiments on the space station to look at biological mining of elements from rocks using microorganisms. So very interested in all the ways in which life on Mars might be useful for understanding the possibility that planet once hosted life, and how we might also use life to support a human presence in space.
Sure. Do you think it's that Mars is the place that we might find life first in the solar system? Do you think there are other planets or moons that are better, that have better possibilities for searching for life?
Yeah, I mean, there are places like Enceladus, the icy moon of Saturn, that we know has an abundance of liquid water and organic compounds. We have found organics on Mars, and there's certainly evidence for liquid water in its past. But in the present day, Enceladus has abundant organics and liquid water. So if you want to look for living microbes that are alive today, I would have thought going and collecting a sample from Enceladus, from the plumes of Enceladus, would be an obvious thing to do, just because it's easy. Well, it's not easy, it's a long way away, but it's easy to get a liquid water sample with organic material in and bring it back to the Earth. That seems to me like an obvious target. Where we'll find life first, well, of course, I suppose life elsewhere in the solar system, and has there been, that remains the open question. And we might find that all these places are lifeless. Some of these planetary bodies may have been habitable but remain lifeless. So I think it's an open question. But I would think if you want present day life, I would go to Enceladus. I still think Mars is very promising. This is a planet that had a lot of liquid water for sustained periods of time in volcanic rocks, in habitats that look like the sorts of places where you find life on present day Earth and probably would have been habitable on early Mars. In terms of the ancient life on Mars, looking for evidence of ancient life on Mars, I think that that is also a promising place to go. Of course, there are other places like Europa, which may be possible to sample on the surface. Maybe even Europa has plumes. And then in the very long term, who knows? It looks like there's evidence for liquid water beneath the surface of Pluto. Maybe we should be looking for biosignatures of life on the surface of Pluto. So that's another place we could look at.
If we do find life in the solar system, how would this change the Drake equation? And maybe if you could just give sort of a bit of a primer on what the Drake equation is.
Yeah. So the Drake equation is an equation that approximates the number of communicative civilizations in the galaxy, or more widely, if you want to modify the equation. And the equation just contains terms that give probabilities, fractional probabilities of, for example, the fraction of stars that have Earth-like planets, the fraction of Earth-like planets that might be able to sustain life, fraction of those that might have intelligent civilizations. The Drake equation is useful for framing the question of, what are the parts of the calculation required to work out the number of civilizations in the galaxy. Its problem, of course, is that there are some terms in there, like the lifetime of a civilization, that we have no idea. And in fact, we can only really empirically determine that by going and looking at the lifetime of civilizations in other parts of the galaxy. But if we did that, then we would have the answer to the Drake equation already. We would know how many civilizations there are. So one of the paradoxes, I think, of the Drake equation is that to get some of those terms in the equation, you sort of have to know about civilizations in the galaxy and therefore have pretty much an answer to N anyway, in which case you don't really need the Drake equation.
Technosignatures or biosignatures? What do you think we should be looking for? Maybe also if you could explain sort of the difference between those two things.
I think it's good to look for both of them. I mean, if you're looking at atmospheres in other planets, why wouldn't you look for trace gases that might be a sign of an intelligent civilization? Although, of course, those gases may be at very low concentrations, so they may be difficult to detect in the near term. I think as a scientist, you should look for everything, everywhere. There's no restriction on this, and particularly if it doesn't cost much. When I say it doesn't cost much, if you're looking for exoplanets and you're looking at the gases in the atmospheres of those planets to try and understand distant worlds, you don't have to be spending a lot more to look and see whether it happens to contain technosignatures of extraterrestrial civilizations. So you're sort of going to do that anyway. Which should we look for as a priority? I would probably look for biosignatures, in other words, signatures of life in general, rather than technological civilization, only because these sorts of signatures are probably at higher concentration. For example, on our own planet, 21% oxygen formed from photosynthesis. This is a very high concentration. It's much easier to detect with a telescope than some trace gas from industrial pollution. In terms of what we might be able to detect in the next few decades, I would go for biosignatures before technosignatures. But as I say, once you've got the capacity, you might as well look for both of them.
I do love the philosophy part of space as well. And if you want to talk about the extraterrestrial liberties, I think it's a very interesting project.
Yeah, and I'll plug a book while I'm at it. I have a book coming out with Oxford University Press in June called Interplanetary Liberty: Building Free Societies in the Cosmos. So why am I obsessed with extraterrestrial liberty? I've always been interested in political philosophy, organizing human societies. In some sense, it's a very sort of scientific thing, actually. How you build a civilization, just think is really fascinating. I started reading political philosophy about 20 years ago, or just beyond that. I started reading things like Rousseau and Tocqueville and other people. And as I got reading that, I just thought, this is really great stuff. I wonder what people have said about this in space. And so I dug around, and what I realized is that people have written about societies in space, and science fiction writers have written, Robert Heinlein's The Moon is a Harsh Mistress is a classic revolution in space type yarn. But there's very little academic writing linking it with, ancient academic discussions on liberty that go right back to, ancient Greece and constitutions discussed by Aristotle. So I thought, I'm going to write some stuff on this because there's not much out there. And for me, so then I started writing about liberty in space. And you might say, why liberty? And the reason why that fascinates me is just because I think it's the core of human civilization, and has been the core of all, when I say the core, I mean one of the most fundamental questions that shapes our societies is how much authority or not we give to the people who rule over us. And this, I think, is a perennial problem. Primates even experience it in dominance displays and how much they ignore the top gorilla. This goes on in animals, and it just feeds over into humans, but in a more rational, contemplative way than one sees in animals. But the question of who has the authority and how much is fundamental to any group of creatures that seek to organize a society.
Sure. I mean, I think having started this project to the Golden Record, I think one of the questions I do like to ask is what I would ask an alien if I met an alien. And generally on the top of that list actually is what are their systems of politics, of economics?
Yeah.
What do those systems look like in a different place? And are there sort of universal things that are similar? Because it is something that they would be asking themselves. It is very doubtful that,
I would ask them for good examples of their literature on liberty. And it would be fascinating to know whether, the aliens of the Omega Quadrant have a book that's similar to Thomas Hobbes's Leviathan, or, because we went through these phases where you've got Aristotle thinking about constitutions 2,000 years ago. And then you sort of progress, and you've got people like Hobbes who says, well, if you want to get out of the state of nature and not have chaos, you need a Leviathan who manages all of society. And then you've got other people saying, no, it's a limited social contract where people only get together to prevent the worst outcomes. And these are quite generic discussions. So I'd love to know whether the aliens have similar authors, not Thomas Hobbes, but, Zogglezig, who wrote that fantastic book about, you need central control in the alien society to run it properly. Do they have books that represent identical parallel lines of thinking that we've had through the history of political philosophy? If they're a more ancient civilization, what's coming up in the next sort of 3,000 years in political philosophy? So can we predict what we should be talking about?
Sure. For the younger part of our audience, if this is something that is interesting to you, we do have a member of our team who is a space anthropologist.
Excellent.
I don't think that was a job a couple of decades ago, but a very, very interesting line of anthropology. Coming to the Golden Record, what do you know about the original Golden Record?
I know a bit about it. I know, the team I know they had a very short period of time to put it all together. And I've seen that book. what's it called? Whispers from Space.
Murmurs of Earth.
Murmurs of Earth. Yes, I've actually got a copy of that. It's not on my bookshelf. I think it's at home. Yeah, so that's the sort of iconic summary, isn't it, of how that record was assembled and what's in it. I think they did a reasonably good job, given they had to do it quite quickly. You know, the images seemed to capture a lot of what was going on the Earth. They did make a good effort to get diverse sources of music and discussions and images of different religions. So in terms of a snapshot of Earth, I don't know whether I think the culture and the music is good fun. I would have had a bit more maths and science in there. And I also would have been sharing maybe some of the political philosophy. I think if I was an alien and I picked up a golden record from a spacecraft and I excitedly put the needle on and ran it, and what I got was Chuck Berry and a picture of a hamburger, I would be pretty disappointed. Well, as we said earlier, what I would want to know is, what are the political systems on this world? Can we learn anything? Do they understand the scientific method? Surely they did to build the record in the spacecraft, but who knows? Maybe they have a completely different view of how to do science. I'd like to know about that. Or is it exactly the same as our scientific method? So I would fill a record with documentation of our civilization and our knowledge, our fundamental knowledge about science and politics, our views of history. And what I would call, it's never objective knowledge, because our history is very idiosyncratic and contingent on how things have happened. But they might be very interested to know, did this civilization go through a phase of having these sort of absolute monarchs that controlled society, and then the emergence of democracy? It'd be really interesting to record for the aliens the general facets of our history and the types of organizations and governments that we have experimented with, because maybe they've seen the same thing in their own society. They'll go, oh yeah, it's just like us. Or they may go, this is amazing. How did they not discover democracy as soon as they emerge as a species? Or democracy, wow, this is an amazing system. Why did we never think about this? So I think there's a lot, either they'll learn nothing, but in learning nothing, they'll realize that we are exactly like them, or the fundamental knowledge will be very different, in which case they'll learn something. So either way, I think it would be very interesting to do a record that, as well as the images and the music, really documents some basic information about our societies, politics, science, technology.
I think part of this project for me as well has been, how to not have sleepless nights and what's going to go on. And I'm essentially not making those decisions, but we have to set up some sort of a structure where those decisions can be made. But with putting Wikipedia on, it takes a lot of the potential, some of the arguments of out of, we kind of have, it's not a perfect system, but there's general consensus that it is a form of an archive which is relatively accurate and kept up to date.
Yeah. It's also a good, it's a good reflection of the good and bad points of humanity. You'll find it all in there, whether you're looking for, the biography of Adolf Hitler or Solzhenitsyn or whoever it is. You've pretty much got all faces of humanity in Wikipedia. They'll get a pretty good snapshot of what we are and what we're about. It's an interesting question. That's an interesting question because, of course, Wikipedia is constructed by a certain cross-section of humanity. And, of course, it's written by humans. So we write about people we think are bad in particular ways. It would be interesting to know how aliens did, in fact, interpret Wikipedia if they read it without a human mind, how an alien mind would read that and what they would conclude.
Is there anything that you're particularly excited about in your field over the next couple of decades?
I think exoplanet searches, looking for biosignatures in the atmospheres of exoplanets, is probably one of the most exciting frontiers, just because beyond our own solar system, there are thousands of planets we might look at. In our own solar system, of course, we've got Mars and Enceladus, and, that's not unexciting, but it's only, a number of bodies you can count on one hand. But exoplanets, looking for biosignatures of life on exoplanets, offers us the opportunity of assaying or looking across thousands of planets, maybe many, many more, across vast areas of space. And that's exciting because we may finally get some statistical handle on whether there is life out there and how common it is, at least whether, there's biosignatures of life. So that, I think, is very exciting. And of course, I remain excited by the possibility of the human expansion beyond the Earth, landing on Mars. I hope that the dreams of those who want to do that, Elon Musk and others who are building the technology to get to Mars, I hope all this will come to pass and we can build a self-sustaining settlement on Mars. And I think that would be fantastic. Then I can write a book about political philosophy of a real society rather than just mindlessly speculating about this stuff.
Sure. Do you think life has a purpose?
No, I think it's an end product of biological evolution and it's not going anywhere. It's utterly pointless and purposeless. But that is not, but we have to decide on our own purposes. And as the famous saying goes, here we are, so here we are. It sounds a really trivial thing to say this, but
I like it.
We exist, right? We exist.
Yeah.
And unless we're planning on some collective suicide to finish ourselves off, which we could do, but I think that would be a bit silly. But now we're here and we find ourselves as a consciousness contemplating the universe, and we have no purpose, I think. The next question is, what do we want to do with ourselves? Because this is fun. It's sort of interesting existing and looking out into the universe and building particle accelerators and telescopes and trying to figure out what this is about. And we should decide, how can we make this an interesting existence, both in the here and now. So for the minds that currently exist, we want to live pleasant lives that are fulfilled and exciting and interesting. Space sciences and building records for aliens is part of enriching our lives. And we also need to think, how do we continue this into the future? And you might say, why would you want to do that? And I was trying to explain this to someone the other day, because ultimately the universe will die in a heat death. So even if we keep going for a quadrillion years, we're going to be dead at the end of it. So why not just kill ourselves off now? And my response to that is very simple, that we don't know that we're going to be dead in a quadrillion years, because by that time, maybe we can create a universe in the laboratory. Maybe we'll discover we are one universe in a multiverse, and we will have, our physics will allow us to move to another universe that's got another quadrillion years. So with that time left, I'm not convinced it's a closed question that we are ultimately, even in the very, very long term, completely doomed. And so the fascinating question is, can we just carry on as an intelligence occupying new universes into the indefinite future? So that's a good purpose to exist, to pursue this question and to give our descendants the opportunity to answer these questions. But we do have to decide what our purpose is, because there's no preordained purpose laid out for us. If we don't decide on a purpose, then, truthfully, life can just become pointless.
Sure. Talking about purpose, do you have any advice for young people looking to get into astrobiology?
Yeah, I think one of the things I always say is astrobiology is very broad. And some people email me and say, how do I become an astrobiologist? And my answer to that is, decide on what science you find most exciting and then pursue that. So if you're a biologist, carry on doing biology and become a microbiologist, and then use that to contribute to astrobiology. So my degree at university was actually in biochemistry, and my core expertise is in biochemistry and microbiology, and I use that to contribute to astrobiology. I'm not an astronomer. I'm still not very good at that. I'm not that good at geology either, but I learnt those things. But it's always good to come to the table with a deep understanding of one area of science and then build on that. So my advice is, don't try and become an astrobiologist or look for degree programs necessarily in astrobiology. Focus in on what's my favorite science. Is it physics, astronomy, biology? Continue to take an interest in that. If you want to go to university, do a degree in that, and then use that as a springboard to talk to biologists or astronomers or whoever else it is, and get involved in the exciting area of astrobiology. But, you can become an astrobiologist at quite a late stage of life. In my early career, astrobiology didn't exist. So even my PhD, I was doing medical molecular biology. I was looking at blood clotting proteins. Although I had an amateur interest in space, I couldn't indulge it because astrobiology didn't exist. So you don't need to be an astrobiologist at a very early stage. You can always go to astrobiology meetings and take part in that later. And what's thrilling about the field now is that there are societies and meetings which were not around when I did my degree and PhD. So you can take part in those and become part of the astrobiology community without needing to call yourself necessarily or be trained as an astrobiologist. Call yourself an astrobiologist. So that's my advice. Just carry on being enthusiastic and pursue the things you like most, and get in contact with astrobiologists and contribute to that field. Yeah.
Super. In closing, is there anything that you would like to add or talk about?
No, I mean, I think it's, I would only say, I think this is a very exciting time to be asking these questions about, how did life start on Earth? Does it exist elsewhere? And we're finally going to get answers. People in ancient Greece, I mean, the ancient Greeks didn't quite understand the universe like we do, but they asked similar questions like, are there other Earths or other worlds in the cosmos? So we've been asking these questions for 2,500 years. And finally, in the next few decades, in the lifetime of young people watching this, you're going to be able to get answers on whether there is life on other planets, at least in our solar system and beyond. And even if it's nothing, that's still an answer. So really exciting that finally we're going to know something about one of the deepest questions that the human mind has ever asked. Is there life elsewhere in the universe? So I think it's a great time to be involved in this and getting involved in astrobiology and science in general, actually. So my last comment is just to encourage anyone watching this who wants to go off in a career in science. Yes, good idea. Do a career in science. Maintain your sense of wonder and enthusiasm, and do not let anything in society take away that childish sense of wonder for the universe around us. If we don't have a childish sense of wonder for this whole thing of existence and the universe, then our lives as little creatures on a piece of rock orbiting a star are greatly diminished.
Sure. That's fantastic. Thank you. And thank you for your time. We really hope you do accept another invitation at your whatever times that you're going to be available. Thank you also for your contribution.
No, thank you, Nick. Thanks a lot. Thanks for inviting me. It's been great.